A warm welcome to all the viewers. In today's session of Tourism and Hospitality Research, we will be discussing about how to do structural model assessment in AMOS. You might like to go back to look into the measurement model assessment, which I showed you in two parts and conducted through confirmatory factor analysis in AMOS. Now, once you have confirmed that the measurement model is good to go, the next step is assessment of the structural model. So we'll see how it is done in AMOS. These are the model fit thresholds which we saw during the measurement model assessment as well. In the structural model assessment also, we need to compare the observed values to the model fit thresholds, which are stated over here once again. So we will be comparing our results to assess whether our model fits well or not. So here we are in our model. You can see this was the measurement model where all the latent variables, food quality, cultural authenticity, service quality, value for money, and behavioral intention. This consists of four independent latent variables FQ, CA, SQ, and BM, and one dependent variable, that is BI. All of them are measured through four indicators each, which are measured on a Likert 5-point scale. So now, in order to assess the structural model, we need to remove the covariances. These are the covariances. So I'll click on this cross thing and I'll remove the covariances like this. So now once we have removed the covariances, I need to click on this single headed arrow and I need to connect it to the dependent variable. So every independent variable in this model is projecting the dependent variable. So this is a case of multiple linear regression. Like this, we have connected all four independent variables to our dependent variable BI. Now, one important consideration over here is that all independent variables should be covariate with each other. So that is a requirement. For that purpose, I'll again click on double-headed arrow and connect all my independent variables, covary all my independent variables with each other, because it is a requirement for covariance based structural equation modeling, CBSEM. So we are doing CBSEM here in AMOS. Now we need to check whether all latent variables, independent latent variables, are connected with each other or not. So 1, 2, 3, it's connected with 3. 1, 2, it is missing on 1. So I need to connect it with the third one as well. Now it has 1, 2, 3, 1, 2, 3. So I'm just counting on the arrows 1, 2, 3. So that means all my latent variables have been connected with each other, the independent latent variables. They have been covariate. Now, there has to be an error term on the dependent variable. How to do it? Go to this, add a unique variable to an existing variable. So I click on add a unique variable to existing variable and come to BI, and that is how I add the error term on dependent variable. Now I need to name this error term. Go to plugins and name unobserved variable. So now you see E21 is the error term on my dependent variable. I hope it's getting quite clear to you how to name, how to do the covariance between your independent latent variables, how to connect the independent latent variables to the dependent latent variable, and how to introduce the error term on your dependent variable. Now, we will run this model. So I'll go to calculate estimates. So I clicked on calculate estimates. The model ran well. The chi-square value which we got is 358.8. So now one by one we'll be checking all the things which are required to be checked for structural model assessment. First of all, click on this red button and go to standardized estimates. So in standardized estimates, you see All of these are factor loadings. These are factor loadings. And then I can see that none of them is below 0.5. So we see that all the outer model, this is known as outer model. The relationship of the indicators with their latent variable is outer model assessment, which we did in the measurement model assessment. So all the factor loadings have to be greater than 0.5. So we see all of them are greater than 0.5. In case any of them was lesser than 0.5, then we have to remove it from our model during the measurement model assessment itself. Now, these are the path coefficients. You see 0.39, 0.38, 0.15. So these are the path coefficients. The hypothesis laid down for this model is that food quality significantly affects behavioral intention. Cultural authenticity significantly affects behavioral intention. So, we are trying to find it out that whether our alternate hypothesis which we laid down is accepted or not accepted, because the null hypothesis in this case is cultural authenticity does not significantly affect the behavioral intention. So in case this path coefficient which you see over here 0.38, the p value for this is insignificant, that means greater than 0.05, then we fail to reject the null hypothesis. There is no significant relationship between cultural authenticity and BI. So in that case, we will say there is no significant relationship between cultural authenticity and BI, because the p value which we got is greater than 0.05. In case it was lesser than 0.05, then we reject the null hypothesis and we go with the alternate hypothesis, which says that there is a significant relationship, a significant positive relationship between cultural authenticity and behavioral intention. Now, this was the discussion which I did through this model. Now, I will go to the results section and see them in the tabular form through view text option. You see view text option over here. So I'll go to view text option, and now you see the chi-square value, the probability level is 0.000. Ideally, it should be above 0.05. But since you have a large sample size, the chi-square value is quite sensitive to the sample size which you have taken. We'll go to the model fit to check. Now you see the first is C-min by DF. So the threshold is it should lie between 2 to 5. So it's okay for now. Then we see, I'll put that thing in front of you so that we can assess it side by side. Now you see GFI and AGFI greater than 0.90. So here it's 0.85 and 0.80. So not that bad, but still we can improve it because we have to achieve it greater than 0.90. CFI and TLI greater than 0.90. CFI is greater than 0.90, it's 0.915, TLI is 0.899. So that can be rounded up to 0.90. We have a scope of improvement in TLI as well. RMSEA, root mean square error of approximation. The value has to be lesser than 0.08. So you see here 0.078. So it can be accepted. Now SRMR should be less than 0.08. How to get this SRMR? Go to the model, go to the plugins and click on standardize root mean square value, and you will automatically get it once you will click on calculate estimates again. Now, after checking it, we confirm that this value of SRMR is lesser than 0.08 as per the prescribed threshold. So we are good to go. So now for checking the relationships, we can do it through estimates also. Go to estimates and see the regression weights. Now, you have regression weights and you have standardized regression weights over here, you see. So what we need to do? We are trying to assess the inner model now. The relationship between the independent latent variable and the dependent variable. We are not interested in these indicators because we have already assessed them in our measurement model. So these four you see here, FQ affects BI, CA affects BI, SQ influences BI, and VM influences BI. So we need to see their relationship, whether it is significant or not. Now, if you see the critical ratio CR, which we get by dividing the estimate by standard error. So once you divide estimate 0.211 by standard error 0.104, you will get a critical ratio value that is 2.020. Now this value is a T value. This is T value. So it has to be greater than 1.96. So it is greater than 1.96. The p-value has to be lesser than 0.05, as I discussed earlier also, so that we can reject the null hypothesis and we say that our p-value is significant and there's a significant relationship between food quality in affecting the behavioral intention. Now we look at CA. Yes, in CA also the critical ratio is above 1.96, it's 2.856, and p-value is lower than 0.05. So we say there's a significant relationship between cultural authenticity and behavioral intention. Now, how to write them in a tabular form? So these standardized regression weights we take in the estimates column, and then in front of them we mention the critical ratio and p-value. So I'll take you back to the slide to show you how it's done. So this is the table in which we put the standardized regression weight. You see here independent variable to dependent variable. As many independent variable and dependent variable you have, you can write down here. Then write the t value or the CR, the p-value, and decision of acceptance or not acceptance of the alternate hypothesis. You can write over here. Now, after assessing the relationship between our independent and dependent variables, we go to assessment of R square or squared multiple correlations. You see here squared multiple correlations. It is same as R square value, which is the coefficient of determination. Now, you see here squared multiple correlations. BI, which is the dependent variable, 0.419, that means 41.9% of the variance in dependent variable, that is BI, is attributed by the independent variables VM, SQ, CA, and FQ. So that is how we interpret the squared multiple correlations. We can see it in the model also. 0.42. I got this value by clicking on this red button and going to the standardized estimates 0.42, which we saw here in the table also 0.419. So that is how you assess your structural model in AMOS. Now, these are some of the useful resources which you can refer to. Read further to understand the concept of structural model assessment in AMOS. I hope the video was quite informative and useful for you. Keep learning and keep watching for more. Thanks a lot.